Okay, so further discussion on probabilities will proceed. Probability is not very difficult. It comes under kind of a simple topic, but if it is not understood, then it can be very difficult. Okay, so probability is about understanding problem space. So, what is probability is means what is the chance of something to happen. So, a deep understanding of the problem space is required. As much time as possible should be given to understand the problem space. Creating sample space. So, once problem is understood nicely, then sample space of items should be created, picking required item and calculating the division. Okay, so how we understand the problem space and then how we create the items in sample space and how we pick the items. So 99% of the work is here, or probably 100% of the work is here, and then these are minor. Okay, understand problem domain. So go in deep and try to give. Okay, so like if the problem is in kind of iterative or recursive, okay, in a meta way, that is the better English. So if it is in a meta way, then go in the kind of inner frames and till you hit the kind of the scene that, okay, so this is the problem. Think about the main actor in the problem. There can be many actors in the problem. Okay, one actor will carry the key. So that is the guy who will create the problem, who will make you understand the problem space. So problem space need to be think, give as much time as possible and go in depth of the problem. Okay, then decide for the actor or guy who is the problem, and that can explain this idea in detail, then we can think about the solution. Okay, create sample space of items. So based upon the actor, whatever the actor we have selected, now we go with many items. Items can be orthogonal. So later we'll see in Bayes' theorem. Okay, items may not be orthogonal. So like we can see there are many items, not actor. Many items are there and they may be intersecting each other at some point. So if there are 4 items, okay, these 4 items, they make the complete problem domain or complete sample. If I add all 4, then it is equal to 1. So if I add all 4, it is equal to 1. Okay, so idea is if I add all 4, then adding all 4 should become 1. Okay, so that is the idea. Now create sample space of the item. So inside that, this green, whatever green we are seeing, here we are interested in. Okay, these are the full items that are in the problem domain, and then all the greens what we see, here we are interested in. Okay, not everywhere. This is crucial. So in problem space, only green color we are interested in. Once we know it, then we have to pick the places what we are looking for against what we are interested. What we see in the black background, that we are not interested at all. So what is the probability where we are interested in, and then total green. So since I have colored these two as orange, so I have made green plus orange. Otherwise we can say total green. So total green is denominator and orange color is numerator. So this is what we are looking for among all green. What we see not selected, not colored, we are not interested in. So that is the probability. If we understand this much, okay, first understand the problem, find the guy who is the problem, and then, so this is full domain where all items exist, and we are interested in these many regions, and inside that we are picking these two. If we are picking these two, then whatever we are picking by whatever we have opted for, that we have to divide. Non-colored region we are not interested in. Okay, so now the question is, a coin is tossed 3 times. Okay, so a coin is tossed 3 times. What is the probability of getting head, head and head? A coin is tossed 3 times. So as per the discussion, we can kind of think like there are 3 coins as we have discussed. Okay, so it is as good as there are 3 coins. I can say like this. Okay, so there are 3 coins. It is as good as saying like this. There are 3 coins. Okay, and who is the actor? Actor is a triple coin, means 3 coins. That is the actor. Okay, now we create the sample space of items. So we have 8 items. A coin is flipped 3 times, but it is creating, as per the actor, it is creating 8 items. These are items, and items we can see head, 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 tail, like that. And it is as good as these 3 coins are tossed in various combinations. Okay, so what will happen if I compute a kind of, if these 3 coins, they are tossed in various combination, so what would be the result? Okay, so that can be thought of. Now, select the item. Okay, what you want? You want this. Out of all combinations, you want this. So, if there was question like what is the probability of getting head, head, head and tail, head and tail? Okay, this is the question. Head, head, head and head. So, now we have 2. This and tail, head and tail. These 2. Okay. In that scenario, it will be 2 by 8. Now, here we are question is only head, head and head. So, it is 1 by 8. Okay, now I have another question. A bag contains 2 blue balls, 3 green balls and 2 red balls. Okay, so the way it is drawn, I believe it is opposite way, so I'll change it. Okay, so a bag contains 3 red balls, and 2 green balls. Okay, so this is pretty straightforward question. A bag contains 2 blue balls, 3 red balls and 2 green balls. At a random 2 balls are picked. What is probability that picked balls are not blue? Who is the actor? Dual ball. We are picking 2 balls. Okay, so 2 balls are actors. If they are the actors, now we have many items, and in each item we have 2 balls. Ball 1, ball 2, blue 1, blue 2, blue 1, R1, blue 1, R2, blue 1, R3, blue 2, R1, blue 2, R2, like that. Okay, so in every pick, it becoming one item, and each item is like this. Where we are interested in? We are interested in all the items where blue is not coming. If that is true, then there are 10 items where blue are not coming, and there are total 21 items. So the division, if we make at the end, then it will come as 10 by 21. Okay, so no one has guts to draw this one and then find this one. So if 2 balls, blue ball, 3 red ball and 2 green ball are there. So blue, red and green, then we have to find combination of 2. So we select any 2 at any time where 2 can be shuffled, like 1 blue and 1 blue. Blue 1 and blue 2 are same as blue 1 and blue 2 are same as blue 2 and blue 1. So it will not be permutation, it will be combination. Okay. So whatever we are selecting, their intermixing is not required. So if I say blue 1 and red 1, and if I say red 1 and blue 1, so both are same. So we will use combination. So blue, red and green, whatever they are in the count, combination 2. So every time 2 are selected. So if I do that, it will become 21. Now, what we want, red and green combination 2 where blue is not there. So it will come as 10. So 10 by 20. Okay. So, but in mind, this is not a bad idea to think about the sample space. Okay. Whenever we go for probability, we find the actor, we think about the sample space. Once we think about the sample space, then we think about what we are going to pick up, and then how we create the sample space. Then we can think about the permutation and combination. Okay, so that is the scenario how we calculate the probability. So at the end, so like here, whatever the combinations are happening, we are taking all the combinations in the example, and then we are picking whatever we want and we are dividing. But in conditional probability, means probability can be of multiple grade, complex also. There we will see that this diagram has importance. Right now we are selecting everything, and then we are picking the item, and then we are dividing it. So that is the scenario.